Dr. Jack Cohen, like I said, a scientist with the U.S. Forest Service for many, many years, and the one behind the home ignition zone and sort of the development of that with a whole bunch of experiments up in the Northwest Territories that he may talk about in his presentation, I'm not sure. But yeah, I've had the privilege to be connected with Jack in particular over the last couple of years here. I've done a couple of joint presentations with Jack. He's an amazing guy. He's got some really good words to share with you. So take her away, Dr. Jack Cohen. Thanks.
So I'm on. Good. Let me know if you can hear me and see the slides just fine.
Yeah, we can see you and we can hear you, Jack.
Very good. Thank you. Well, okay. Thank you very much for inviting me to present on effectively preventing wildland-urban fire disasters. So without further ado, what I'm talking about here is wildland-urban fire disasters that specifically address the many homes and businesses and other structures that burn to total destruction during extreme wildfire conditions. That doesn't exclude the wildlands that may suffer significant damage surrounding the community that we may call part of the community. This is strictly the built environment that I'm going to address. But having said that, in order to manage inevitable wildland fire, we need to recognize two contexts of fire. One of fire resilient landscapes, that is to restore fire as an appropriate ecological process, as a natural disturbance in our landscapes, and simultaneously the issue that we tend to focus on, which is fire adaptation, that is preventing disastrous community fire destruction by wildland fire as a natural hazard. So as a natural disturbance, available science has revealed to us that European discovery and settlement in North America significantly reduced wildland fire area burned as a sustaining ecological factor for most landscapes, fire-adapted landscapes, and over particularly the last century of wildland fire suppression, we have largely eliminated wildland fire as an appropriate ecological factor, resulting in a condition that has been called the wildfire paradox. That is, our attempt at fire exclusion has actually increased the potential for extreme wildfire conditions over extensive areas. So in order to manage wildland fire as a natural disturbance, we need to accept wildland fire as an inevitable, appropriate, and essential ecological process requiring wildland fire at landscape scales for all fire-adapted fire regimes, low intensity to high intensity. And this presentation primarily addresses the community threat, wildland fire as a natural hazard. So let's take a look at roughly the last 20 years and look at the trend. So these are just fires where more than 1,000 homes have been totally destroyed. And interestingly enough, this trend can be somewhat summarized that in the US, in the 10 years between 1985 and 1994, about 9,000 homes were totally destroyed. Well, in 2018 in California, 3 fires alone totally destroyed 16,000 houses. So that raises the question of, well, the increased trend of wildland urban fire disasters has resulted in an emphasis on wildfire suppression and control. To what effect has that produced? Well, our current situation is that wildland fire is largely not occurring as an appropriate ecological factor in Western North America, in particular in those fire-adapted ecosystems. And our reactive wildfire suppression and community fire protection approach is not preventing wildland urban fire disasters, as that table indicated. And that table, those incidents only occurred during the extreme conditions when wildfire suppression and structure protection fails. So that presents to us a very profound challenge. How can we restore more wildland fire as an appropriate ecological factor at landscape scales, millions of hectares, and at the same time without having wildland urban fire disasters? So we need to at least question what our failure is doing, and at least search for an effective alternative approach for preventing wildland urban fire disasters. Well, we're in luck because available science reveals how homes ignite during extreme wildfire conditions. And that indicates that wildland urban fire disasters are a readily preventable human disaster. That means that our behavior, our expectations, our desires are principally leaving us vulnerable to wildland fire. And most importantly, science has revealed opportunities for preventing wildland urban fire disasters without necessarily controlling extreme wildfires, which we can't do. So let's start by looking at a scene like this. This is the Paradise destruction during the 2018 Camp Fire. And what do we see? We see totally destroyed homes. Every home in this scene is totally destroyed, surrounded by unconsumed tree canopies. And the first question that was asked to me following this, relatively just a few days following this, was, can you explain this unusual pattern of destruction? And my immediate answer was, this is the typical pattern of destruction. Well, so when a scene like this is viewed, the total destruction, commonly people see the destruction without seeing the rest, the unconsumed tree canopies. So typical patterns of wildland urban fire destruction do not support high intensity wildfire flames sweeping through the communities. And in this particular scene, these homes ignited from lofted burning embers. As it turns out, wildfire flames, the wild flame front, never got to the community. So when we look at Los Alamos and the fire destruction there in 2000, we see total destruction with adjacent green vegetation. These homes ignited with flame contact from low intensity surface fire, coming out off the flank and spreading for several hours after the intense wildfire passed by, on the order of a kilometer away, leaving the structures to be ignited and totally destroyed. Let's take a look at this destruction when the fire was burning in the community. So her homes are burning hours after the wildfire passed the community. Intense wildfire of that Cerro Grande wildfire never spread to the residential area, and houses are burning. And we're looking at that through unconsumed, uninvolved tree canopies. By the way, the video is being taken by the same person that is flying the helicopter. He's alone in the helicopter. So this is what it looks like. And there was no difference in the 2020 Western US fires in Berry Creek, California, Gates, Oregon, and Mill City, Oregon. And the important part about this is, particularly in Gates and Mill City, Oregon, these are relatively big tree forests. So we're talking about coastal Douglas fir and other species. So even with very tall, continuous conifer canopies, we see the same influence. So how is this going on? Well, so here we see in 2007, Southern California, upper elevation conifer canopy community, total home destruction surrounded by green canopies. Well, so being typical, let's take a look at Lytton in 2021. We see total destruction of the homes and businesses in the community with adjacent unconsumed tree canopies. It was a grass fire that initiated the ignitions in Lytton. So unconsumed tree canopies amid total home destruction indicate that wildfire flames did not spread through the community, burning trees did not ignite the homes, and the trees that have burned, interestingly, were ignited from the burning homes. Well, although initiated by wildfires do not spread through communities. Community fuels structures and vegetation after the wildfire initiates ignitions, then continue fire spread within the community. The community burns without the wildfire. This scene is from Colorado Front Range in 2012, the Waldo Canyon fire. This community burned well after the wildfire had ceased its influence. So how is this happening? Well, we need to recognize that fire is a combustion process that occurs right at the fuel surface. Fire is not a thing that independently travels from place to place like tsunamis, floods, and earthquakes. Fire requires a sustained sufficiency of fuel and heat. So fire spreads when ignition requirements are met locally, right at the surfaces of adjacent fuels in a stepwise process, including extreme wildfires. By the way, this is Northwest Territories, the International Crown Fire Modeling Experiment. Well, so because of fuel discontinuities in communities, intense wildfire flame fronts do not spread into and through those communities. Fuel treatments and fuel breaks principally change wildland fire behavior, maybe not sufficiently, but change within the treatment area. But it doesn't stop fire spread. So let's take a look at this example. First residential street into the neighborhood, there are homes here on the right side. Well, a crown fire spread from the right to this first street and could not ignite the canopy across 12 meters of the gap from the street. But 2.5 blocks of houses continued to ignite and spread to the state highway. How? Because of burning embers, lofted short range into that community from the intense wildfire. So this is what we see when the house is more vulnerable than the surroundings. It doesn't take high intensity in order to ignite, and this is an example of that. Well, so we're still talking about fire as a process. It's determined by meeting combustion requirements local to the flammable materials of the structure. And that means creating insufficient fuel and heat at structures can prevent community fire destruction. But what does that imply? Well, that means wildland fire is determined by the ignition condition local to the structures. And now with wildland urban fire, homes and structures are the fuel, and the heat are the burning materials on and adjacent to those homes and structures. And oxygen is always available in wildland and wildland urban fires. Well, what that does is it tells us that wildland urban fire is a structure ignition problem, not a wildfire control problem. That's actually good news, because during the extreme conditions when the disasters occur, we can't control the wildfire. Well, intense simultaneous heating across wide areas of structures does not occur. It's the local conditions that determine home ignitions. So how big are local conditions? So wildland urban fire research, including modeling, computer modeling, laboratory and field experiments like in Northwest Territories, and disaster examinations have found that a home in relation to burning materials within 30 meters principally determine home ignitions during extreme wildfires. In this area, the home in relation to its immediate surroundings within 30 meters has come to be known as the home ignition zone. Well, importantly, we need to realize that a scene like this of total destruction does not indicate high intensity wildfire exposure. These 4 homes burned from initiation from burning embers and surface fire being generated by burning embers, as well as initiating directly on the homes to burn to total destruction. These homes ignited and freely burned without available protection. So in this scene, local conditions were not sufficient for home ignition and wildfire suppression was not necessary. But alternatively, in this scene, local conditions were sufficient for home ignition and structure protection was not available. So home ignition zone conditions, the home ignition vulnerability in relation to the burning embers, inevitable burning embers during extreme conditions, and burning surface fire within the HIZ, or if it's continuous canopy, high intensity burning within the HIZ determine these results. Well, as we can see in the 2 extremes, in one case, there was high intensity fire burning past the surviving structure and no high intensities on the right. The most effective fuel treatment for preventing home destruction then and preventing wildland urban fire disasters is within the home ignition zones and collectively the communities, not in the wildlands. So how do wildland urban fire disasters occur? Well, given severe fire conditions, the fuel, weather, and topography, given an ignition, we end up with extreme wildland fire behavior, the rapid fire spread, and or high intensities. But let's say high intensities related to our ability to suppress fire. And then we wildfire suppression overwhelmed. Given an exposure to vulnerable communities, we end up with initiated simultaneous structure ignitions. That overwhelms structure fire protection, and the resources can't protect most structures. That means that most structures, if ignited, freely burned without attention, resulting in total destruction and the disaster. So we have extreme wildfire. That is, the wildland urban fire disasters have only occurred during extreme wildfire behavior, whether it's in continuous conifer canopy with high intensity crown fire and high growth rates, or in grass and light shrubs with medium intensity surface fire, but sufficient to overwhelm our suppression capability with rapid flame spread and growth rates. So we have extreme wildfire overwhelming our suppression. But what if the houses don't ignite and burn? Well, at that point, we don't have overwhelmed structure fire protection. And with that, homes that do ignite can have attention, extinguishing the ignition and preventing the disaster. But let's recognize that that ignition resistance is not fireproof. It's not a practical expectation to think that we can fireproof communities. What we can do, though, is provide ignition-resistant HIZs sufficient such that most ignition-resistant HIZs eliminate most ignitions, and ignition resistance enables effective fire protection for structure ignitions that do occur. And that means a home structure ignition approach that creates ignition-resistant HIZs and collectively ignition-resistant communities can effectively prevent wildland urban fire disasters. So in this particular case, these homes didn't require wildfire control to survive. Wildland urban fire disasters can be most effectively and practically prevented by creating community ignition resistance, not by attempting to control inevitable extreme wildfire, which is our current approach. So alternatively, when we look at fire resilient landscapes, attaining wildland fire restoration as an appropriate ecological factor at landscape scales requires us to have ignition-resistant communities. So ignition-resistant homes and communities means having wildfires without wildland urban fire disasters. Thank you.